welcome to another video of QOTD, and today we're going to talk about pure further mathematics, and today is Unit 2, the very start of Unit 2, and in the very first unit of Unit 2, topic of Unit 2, we're going to talk about sequences and series. Yes. And this is a really important topic in math, and once you get the hang of it, it's actually pretty cool. Let's break it down together.
So, what is a sequence? A sequence is just an ordered list of numbers that follow a certain rule. For example, the sequence 2, 5, 8, 11, and 14. See how each number increases by 3? That's the rule behind the sequence.
Yep, exactly. And what is a series? A series is what you get when you add the terms of a sequence together. So using the same example, it will be 2 plus 5 plus 8 plus 11 and plus 14. And we denote this using the sigma sign. And that's a series, specifically the sum of the first 5 terms of the sequence in this case. Raymond.
Now, to talk about sequences and series more generally, we use a formal notation. So let's say a sequence can be written like this, which is why we write A1, A2, A3, A4, A5, on and on until A of n. We write the numbers in subscript to indicate that they're not like to the power of or something, or as a coefficient. It's just a representation of a different variable. This means we're listing terms from the first one, A1, to the nth term, An.
And the sum is denoted as Sn. And in this case, will just be all of these, instead of commas, will be added together.
Yes.
Oh, that's basically it. And then we'll have some key vocabularies you'll want to know. So first is term. And Raymond, what is a term in a series or sequence?
A term is just each number in the sequence or the series, such as 8, 11, which are all the terms in that particular sequence. A common difference is that the number you add each time in an arithmetic sequence, such as for this sequence, the common difference is 3. For another sequence, perhaps, if isn't a arithmetic sequence, such as this, it is a geometric sequence, there is no common difference to talk about, since difference, you can see, is constantly changing.
Yep.
And we will talk about the geometric sequences later in the following video.
Yes. And after that, how do we define a sequence? So there are two ways to define a sequence, main ways, of course. First is the inductive definition. You define each term and based on the one before it. For example, A1 is 2. Very slow scriber here. And then an equals to an take away 1 plus 3, sorry. So then we know A2 is basically A1 plus 3, which gives us 5. And then following that, we have 2, 5, 8, 11, and then 14, and then on and on. So if you keep adding 3 to get the next term, this is like a following trail. Each step depends on the last one. And the second main definition of a sequence, is the deductive definition, which is position to term. You define each term directly using its position in the sequence. So, for instance, we make an relative to n instead of relative to an take away 1. Raymond's just going to give us an example here, which is an equals to 3 and take away 1. And then there we can define a based on its term, which is very convenient when we're looking for very big n values, and we don't have to go down one by one to reach the very big value of n. So this method is much faster if you want to do a specific term without working through the whole sequence. And now we're going to do the wrap up. What is a sequence? Oi!
Huh? A sequence is a list of numbers that follow a pattern.
And what is a series?
A series is the sum of those numbers.
And we can define sequences either step by step, inductively, or using a formula, deductively. And stick around because in the next lesson we'll learn how to find the nth term and sum up all these values efficiently. Thanks for watching. Leave a like, subscribe, and hit that little bell on the bottom. Imagine if I didn't hit record.
Yeah, you didn't.